Hello, so today we're going to tackle something simple. This is survey 3. We are going to tackle a question that was brought on the July series 2024. So that was just a few months ago. We're going to tackle a question there. So that question involved a lot of work. I have simplified it in order for us to see what we can do best. So this is category Steven from Matili Technical. I'm going to tackle that question, so I'll provide the simple outline and some overview of what we have to do and what we must do. So feel free to ask any question, so the relevant questions, and then I'll answer. So the email is provided on the profile. I'll make sure you go and you can ask as much as you want. We'll tackle the questions, so we are going to do that. Let's go directly to the question. So here's the question. So the July 2024 series Knec survey module 3. So here the question goes. So this was the first question provided, a full 20-mark question. So a section of the proposed road is to run through a cutting from chain 300 to 700 meters, and the formational level at 1 in 250 from change, that is chain 300 meters. We have the formational width, which is 18 meters, and the side slopes. So this is the ratio 1:3. So this is the ratio of the side slope. The original ground surface is inclined uniformly at the right angles to the center line at 1:. So this is the gradient that we have been given here. So 1:12. We are going to see all these ratios, what they represent. So from the information in the table 3 here, calculate the volume of excavation by the end area formula. So they have specified the volume to be calculated, so that is the formula. We have the end area formula. Remember, full 20-mark question. So this question is easy, but if you had tackled it without much ado reasoning, this question I'm sure will be hard. So the simple representation, so the questions here. So here we have the table, chain 300, 350, 400, 550, 700. So the changes are not evenly distributed, so they have a difference of more than. So here we have 50, here we have 150, 150. So it's uneven, but that is not of much concern now. So here we have been given the formational level. So this formational level, this is the reduced level given on our proposed. So these are proposed something more of what we had learned on setting out. So here we have been, they have mixed setting out and areas and volume, that is earthworks. So you have to know the knowledge of both those two sections. So here we have the formational level of 178.45. then we have the ground levels at the center line. So these are the ground levels. So here we have 182.32, 181.83, 182.07, 182.30, 181.71. So the center line, they have a division. So by the look of things, so the formational level, that means this is an invert level, because you can see all these ground level are much higher than the formational level. So that means when you are drawing the cross section of the road, so this formational level is found below. That is the invert level for all this data. So we have been given the invert level, which is the formational level here of 1 point, and the point is the last 700 meters. So also we have been given the ground level of that point, we are going to be using those two in order for us to calculate. So the first thing that I'm going to do, I need to find the formational level of all the other points. And why am I calculating the formational level? I need to find the difference in height, because this is the cross section of cross faults, and I need to calculate the height because our formula, as we going to be seeing it much ahead, so our formula, we need the h, so those are the heights. So I'm going to calculate the area of each and single aspect there. So by the equation provided, so here we have, so the changes are the, so the formation level is falling at the gradient of 1 into 250. So this is the gradient that we are going to be using in order for us to calculate the formational level. So this concept is found also in setting out of sewer lines. So here we have the formational level. So we have either a falling gradient or a rising gradient, so between all those changes. Then the formational width is 18 meters. The side slopes, so this is the ratio of the side slope is 1 into 3. Then here we have been given the original ground is inclined in an uniform at the right angle. So here this is the ratio of the crossfall. So here we have, so they are mixing a lot of things. That's why you need to cover the whole syllabus in order for you to get all these concepts. So this is the ratio, so this is the slope, so this is the cross fall slope represented by letter K in the formulas. So this is the normal slope represented by M, and then we have this is the gradient, so that is the slope ratio of the gradient that we are going to be using in order for us to calculate the formational levels of all these unknown points. And we are going to start from here. So this concept, as I'm reminding you again, is from the setting out. So make sure you revise setting out. So here's the combination of setting out and representation from the, so here we have at least representation from setting out and some other artworks. So these artworks, remember that. So let's go ahead. I've already calculated in order for me to maximize the time that I'll be using to explain, so I don't need to spend a lot of time on this video. It will be boring and I'm sure you won't get the concept. So here I am introducing the concept. The working you'll do on your own. So I'm here just to emphasize on the concept for me to show you how to calculate this. I think you have a calculator, and calculations can be done personally. So I am here just to make sure you get the concept. So I know people ask, oh, why don't you explain your videos in details? Because I'll be spending here at least more than 1 hour, of which that will be a boring video. You will forward it and you will not get the key concept. So I'm here to emphasize on the key concept. So please add here to this. So this is the falling gradient from change 300 meters to 700 meters. So the ratio of the falling gradient is 1 into 250. So here we have a change 300. So we could start from down here. So here we have already been given the changes. So from this question here, you can see the formational level. So I was given the formational level of change at 700, and already the ground level at the same change. That is the data that I'll be using moving forward. I'm sure if you have passed around some videos on the setting out, this will be easy for you. So here we had the falling gradient, but I'm moving in reverse. That means I'll be adding because I'm moving from the highest point to the lowest. So the gradient was falling when you move up down. so I'm going to be doing the reverse. So here we have the gradient. So this is the formational level of the 700 meter. So I'll add the ratio of the gradient, that is 1 into 250 multiplied by the distance covered between 300 and 700. That's why I'm minusing there, and I'll get the formational level of the 300 mark. The same will be done. So you reduce the distance, that is the only difference that is being covered here. So the formational level remains. So this is the simple way. You can also do the formational level of each one and every one of them starting from where I want, but I'll be using the formational level that we have been given moving forward. So I'll be adding the ratio and the difference in the distance covered there. So I'll get my formational level the same. So again, for the 400 meter, I'll be using the same formational level of 700 meter plus the ratio multiplied by the difference there. So 700 and 400, that is the difference. Then the last point also, so the difference in the data provided here. So that will be all. So I think much is covered on the setting out. So this was just a simple, by the way. So you remember, go back to setting out works, either the sewer line, the road, the culvert, and even the building. So this is the concept that I have used. So I have gotten all those formational level provided for the changes that I'll be having here, after which I'm going back to the main formula. So the formula of the crossfall, W is equals to, so this is the side width, is equals to B over 2 plus M H, again multiplied by K over K minus M. Then the second width, side width, is equals to B over 2 plus MH multiplied by K over K plus M. So these are the formulas that are being used in the presentations. So these are the formulas that are gotten from the crossfall. Then, so the first thing you have to calculate at the side width, because those two are going to be used on the final formula of calculating the area by volume. So the area is equals to 1 over 2m into P over 2 plus mh, and then multiplied by W1 plus W2, then minus B squared over 2. So B, as we had been given here on the equation, that is the formational width, and then we move on. So M, this is the ratio of the side slope, that is 3. So 1 into 3, so that is 3. Then the ratio of the crossfall is 1 into 12, that is 12 here. So this is the representation from the data that we have been given here on this part of the question. Moving on ahead, I'll subtract the H, so the formational and the ground level. So I'll subtract the ground level with the formational level. I'll get all my H's for the various areas. So where we have the representation, so the ground level minus the formational level, it will give me the H's for the separate areas that I'll be calculating. So here we have multiple areas on which we'll be calculating by the use of the formula of the crossfall here. So this formula is what I'll be using to calculate all those areas. Then later I'll have to do the volumes. So this is the first one that I have done. So the side width is equals to 18 over 2 plus 3 multiplied by the so this is the H gotten here. So you can see there. So that is the first one. Then multiplied by 12 over 12 minus 3, so this is k over k minus m. So you get the sides width, the first side's width and the second side width. So use your calculator appropriately. So make sure you observe the body mass for the simple calculators. So if you have an fx, so the calculator displayed here, you can input the values all of them together and they'll give you the final of the formulas. So here again we go. So the area is equals to 1 over 2 times 3. So the formula here that we will be, so 2 multiplied by m, that is the ratio of the slope, that is 3, into 18 over 2 plus 3 multiplied by 2 0.23, that is the h, then again multiplied by the addition of w1 plus w2, so found here following this this formula here. So w1 plus w2, on which we have already gotten them, so the addition of those two data here, then minus 18 squared over 2, our final answer. So area 1 will be 61.87 meters squared. So I'm doing this faster because I don't want to waste your time. So as long as you get the simple concept, I know you'll calculate all the others. So we do this. So this is the first area. We do it for the second area. So by the use of this height, you do it again for the third area, the fourth area and the fifth area by the use of the formula from crossfall. So by the use of this formula crossfall, you do area 1, area 2, area 3, area 4 and area 5. So the only difference that we'll be having we'll be having all the, so we have the w1, w2 and the h. So the h will provide for us the difference in all those datas. So you do the same, so you do for all the others, and finally, without wasting much time, so you do for area 2, area 3, area 4 and area 5. Then you go to the formula of volume by s. So this is the volume of the excavation by the end area. So the end area volume is equals to d over 2d is the distance covered between those areas. So is equals to area 1 plus area 5 into brackets, so plus 2 area 1. So these 2 multiplied by the areas that will be remaining. So the end area method, so that is that we can say again that is the trapezoidal rule for volumes. But again you come back to the question. So our question, the d we had the interval. So here we have our d is 50, here is 150, the same here is 150 and the last part is 150. That means the final formula for the end area method will have to use the simplified formula. So the simplified formula, so v is equals to, so that is area 1 plus area 2 again divided by 2 multiplied by d. So this is the formula that we'll be using. So we'll have to calculate volume 1, volume 2, again area 2 plus area 3 over 2 multiplied by d. So I'm using this formula because the d, the difference in the height or the height or the distance covered is different in all the areas. So you'll use this formula because this formula provided here. So v is equals to d over 2 into area 1 plus area 5 is used when d is common, and as you have seen here, our D is not common, so our D here is not common. So here we have a difference of 5. All the others are 150. So that's why you can also combine that formula. It's up to you. So you can do that for the first one, then the other common ones you can use this, or you can just separately do this. So volume 1, volume 2, again volume 3, that will be area 3 plus area 4 over 2 multiplied by D. Then volume 4 will be area 4 plus volume area 5 over 2 multiplied by D. So multiplied by D there. Then after doing that, you'll add all those volumes. So volume 1 plus volume 2 plus volume 3 plus volume 4, and you'll have gotten the final total volume. So the additional of all those volumes you will have done. So that is the end area method. So I've done that calculation. So I'm only here to explain. I'm not doing the whole part of the calculation. I hope you will bear with me and you'll attempt that question. So this is just the concept that I'm giving you. I'm not calculating the whole question. So this is just a simple thing that I'm doing for you. So you'll have to work out all by your own in order for you to get all those correct answers. So I'll leave you up to it. I will be seeing you when you will be doing other simple questions. Thank you.